Memory management is one of the most critical aspects of programming in C and C++. In this video, we will discuss about two fundamental functions in C or C++ for the memory management, that is malloc and free. Using the malloc function, we can dynamically allocate the memory on the heap in the form of a large chunk of memory. Now to use the malloc function, we need to include the stdlib header file. Let's see how to allocate a memory of 20 bytes on the heap. Now we want to allocate 20 bytes on the heap to store 5 integers. So we need to pass 20 as argument into the malloc function like this. It will allocate 20 bytes on the heap and returns a pointer pointing to that memory location. Basically, it returns a void pointer. Therefore, we need to cast it into an integer pointer and assign the pointer value to our integer pointer ptr. Now we want to store 5 integers. And integer is of 4 byte usually, so that's why we passed 20 as an argument. But instead of this, we can also do like this. The size of integer will be of 4 bytes in most of the system, but depending on your OS it can be 2 also. So we will multiply that with n, that is 5, so it will give us 20. So malloc function will allocate 20 bytes on the heap and returns a void pointer pointing to that memory location. And the main difference from the new operator in C++ here is that it will not initialize the memory. The memory will contain the garbage values. We will cast that void pointer into an integer pointer and assign to our pointer ptr. Now using this pointer, we can access the individual values like this, pointer 0, and assign some value to it. Similarly, we can assign or access the remaining values on the memory allocated on the heap and initialize it with different values. Now we can also access these values in a loop. I is less than n, I plus plus, and we will print those values ptr I. N here is in the small letters like this. So what it will do, it will first we allocated 20 bytes on the heap or memory to store 5 integers on the heap using the malloc function. Then we accessed each of the integer individually using the square brackets along with the pointer and initialize them with certain default values. Then we are using a for loop to iterate over those values and print them one by one. And in the last, we can print a new line character. Now if we run this code, we can see it printed each element of the array individually on the console. Now our memory is allocated on the heap and we access them, change the content of that memory using pointers and then printed them. Now there is no more usage of this memory. In that case, we need to delete this memory or deallocate this memory back to heap. For that, we can call the free function and pass the pointer pointing to that memory location event. It will delete the memory or deallocate the memory back on the heap. But the important point to note here is that if we are passing a pointer, we need to make sure that this pointer is pointing to a memory location that was allocated using the malloc only, not by any other function like new. It should be allocated on the heap and by malloc function only or by calloc. We will discuss about the calloc in the next video. Now after this memory is deallocated, after this particular line, pointer ptr is a dangling pointer. Therefore, we always need to initialize it with value null here. Otherwise, if someone tries to access the value using this pointer ptr after we have already freed the memory pointing by this pointer, then it can result in undefined behavior. So now here we access the value on the heap using the subscript operator along with the pointer. But we can do that without the subscript operator. What we can do, we can add 1 into the pointer here and dereference this. What it will do, pointer plus 1 will point to the second element in the allocated memory, and then we are dereferencing it like this. So this line is similar to passing the 1 into the square brackets and then changing the value. And another important point to note here is that if malloc fails to allocate the memory on the heap, then in that case it will return a null pointer. Therefore, after allocating the memory on the heap, we should first check if the pointer is valid or not. Like this. So malloc function will return null in case it is not able to allocate the memory on the heap. Now value of null in C and C++ is 0. So if our pointer has value 0, the if condition will evaluate to false and it will not go into this block. Whereas if malloc function is able to allocate the memory on the heap, it will return a pointer pointing to the start of that memory location. So in this video we learned about how to allocate the memory on a heap using the malloc function. This video is a part of pointers course in C and C++. For more videos related to this course, you can check out our playlist on YouTube, or you can go to our website thispointer.com for the complete course. Thanks for watching. Don't forget to like the video and subscribe to our channel.